So today we're going to do the full MOCA review. This is 40 questions, just like the actual MOCA review, or the actual MOCA test would be. It also is designed to give you 90 seconds per question, which if you took the test and you spent the same amount of time on every question, you would have 90 seconds. Like, I understand in real life, like, some questions you might answer in like 10 seconds and some might take you 2 minutes. But this was just kind of the only way that I could give you like a true feeling of like how to pace yourself. Please do not put your name on your papers. I will be collecting data off of the papers, but I don't need your name for it. And then also do not simplify your answers, and I've given you a few formulas, and if anything comes up that I didn't already write down, I'll write it down again. Okay. So, we're gonna get started. Which of the following represents a pair of vertical angles? Okay. So vertical angles are angles that are kind of catty corner from each other, and they have the same angle measurement. So in this case, it was 2 and 4. 1 and 3 would be another example, or 8 and 6, or 5 and 7. Okay. What is 15 minus 3 times 2 cubed? Alright. I know all you got it right, but for the interest of the video, I'm still going to work it out. We had 15 minus 3 times 2 cubed. So with our order of operations, we would start with our innermost parentheses. That is 3 times 2 is 6. Then we would move to our outer parentheses. 15 minus 6 is 9. And then 9 cubed is the same as 9 times 9 times 9, which would be 729. Alright, which of the following is an irrational number? Okay. Our irrational numbers are numbers that have decimals that never terminate or end. With 5, there's no decimals at all. With 1/5, if you divided that out, you'd eventually get an ending decimal. 5.5, repeating, like, it has an end right here. And then pi is an irrational number because, like, you can recite the decimals of pi like out to the thousands of digits and you're still nowhere near the end. And anything multiplied by pi is still irrational. How many times larger is the diameter of the circle than the radius? All right. So whenever you see pictures like this, the test makers, Pearson, are actually trying to trick you because they want you to think that this 7 inches is important. We know that the diameter of a circle is the area from one side to the other, passing through the midpoint of the circle. And a radius only goes from the outer edge to the midpoint of the circle. So if you had 2 radiuses, it would go all the way through the circle. So the relationship is a factor of 2. Which best defines the zero property of addition? Alright, if you had no idea what the zero property of addition is, you could work by process of elimination. That's a good thing to do whenever you're taking any test, especially these. We know it's of addition, so we can go ahead and throw out multiplied, and the difference, that would be subtraction. And then, so then we're between the sums, and this statement is actually not true. If I had 3 and -2, my answer is 1. So not every positive and negative number is going to add to equal 0. So that left us with the sum of 0, and any number is the number itself. Identify the dividend in 273 divided by 13. Excuse me. So for our dividend, for dividing, you have 3 parts of division. You have the dividend, the divisor, and the quotient. So the dividend is the number that is being divided. The divisor is the number that the dividend is being divided by, and the answer is your quotient. So in this case, 273 is what's being divided. So that would have been our answer. A quick way to remember this would be if we drop the n in dividend, you're looking for what's divided. The multiplicative inverse of 5/7 is what? Good job. The multiplicative inverse's purpose is something that you can multiply by a fraction to equal 1. And so you just have to take it and flip it. If this was a negative, however, you would also want to remember that your multiplicative inverse would also be a negative. It doesn't apply to this question, but it could apply to the MOCA. Identify the mean, median, and mode of the following data. Alright, you guys all got this right. Whenever I work out mean, median, mode questions, I always start with the mode. That is the number that occurs the most in the data set. From this, we could see that 46.4 and 46.4 were the numbers that were there the most, and only one of these questions had that as the mode. That would be the quickest way to do your process of elimination, and then you could go to the median. which is the middle number in a data set, you would have to put them in order from least to greatest, and then find the middle number. If there's 2 numbers in the middle, divide by 2. And then the mean would be adding them all up and dividing by the number of numbers there to find the average of the data set. How does the following histogram differ from a bar graph? Alright, so while it is true that this has the word frequency on the side, not every histogram says frequency. It could have a different label on the side. Also, both histograms and bar graphs can be turned any direction you want to, whether you want them going sideways or up and down, such as this one, and you can use color in either one. The difference in a histogram is that there's an interval of scores between each section. So since this is class intervals, we know that 3 people are in between 60 and 70, but we don't know where between 60 and 70 that is. And if this was a bar graph, it would show individually what each score was. Sarah read the following clock and said it was 12:15. What error did she make? All right. While at first this looks like it's a test of your Roman numeral knowledge, it's actually wanting you to think about what the hour hands represent. So we know that the shorthand represents hours and the longhand represents minutes. So she had interpreted the meaning of the hands incorrectly. Classify the following polygon. Alright, in order to classify it, we have 2 things that we're looking at. The first, we're looking at angle measures, and then we're looking at the number of sides. While it didn't state that this is drawn to scale, we can reasonably deduce that each of the angle measures are the same. So that would mean that this is a regular shape. That would have eliminated the irregular answers. And then you can count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So a 9-sided shape is a nonagon. And that's how we got that answer. Determine the least common multiple of 8 and 10. Alright, so if I was going to do this problem, the first thing I would do is start myself a chart. So we have 8 and 10. The least common multiple is the number that either number can be multiplied, and they're both a divisor of it. And so I would list the multiples until I got two numbers that were the same. So 8 times 8 is, or 8 times 1 is 8. 10 times 1 is 10. 8 times 2 is 16. 10 times 2 is 20. 8 times 3 is 24, while 10 times 3 is 30. 8 times 4 is 32. 10 times 4 is 40. 8 times 5 is also 40. So 40 is our least common multiple. Yes, both numbers go into 80 as well, but we're looking for the smallest number that they both go into. So that's why you might not want to use the guess and check method on this. Identify the greatest common factor of 50 and 120. Alright, in this particular problem, we're giving two factor trees, and we are trying to find the greatest common factor. The greatest common factor is the biggest number that both numbers are divisible by. So when we look at the factor trees of each number, we see that the biggest number that occurs in both of our numbers from the problem is 10. If the factor tree was not provided for you, you could make your own, and I find that's the easiest way to find the greatest common factor. Solve for y. And this 12 here was just a problem number. I couldn't find questions without the problem number for this one. Alright, all of you got this question correct, but for the video, I'm still going to work it out. Alright, so whenever we're solving for a variable within an equation, we want to undo what's already been done until we can isolate the variable that we're looking for. So, in this case, we would start by undoing this division by multiplying each side by 4, which would give us 5y minus 2 equals 12. And then we'd want to undo this subtraction with addition to have 5y equals 14. And then to undo this multiplication, we would divide. So y would equal 14 over 5. A wire is stretched from the top of a 30-foot tree and ends 40 feet away. How long is the wire? Alright, so there are two ways to do this particular problem, and I'll start with the way that you probably thought to do this first, and that is to use Pythagorean theorem, which is a squared plus b squared equals c squared, and that'll certainly work for this. We would have 30 squared plus 40 squared equals c squared. This would be 900 plus 1600 equals c squared. That would be 2500 equals c squared. And then take the square root of both sides. And you're left with 50 equals, that was one too many zeros, by the way, with 50 equals c. The other way that we can look at this is think about our special right triangles. The MOCA and MOGA and even the middle school MOCA absolutely loves to use special right triangles. So this is the most common pattern, which is called the 3, 4, 5 triangle. And so we know that anytime we see a triangle that is a right triangle, this only applies to right triangles, that has legs of 3 and 4, our hypotenuse will be 5. However, what Pearson does to make this less recognizable is they like to find factors of the 3, 4, 5 triangle. So you see here, it's 30, 40, 50 instead of just 3, 4, 5. So each of these factors are multiplied by 10. And that's an easy way. So if you have to, like, before you go in to take your MOCA, just think 3, 4, 5 triangles, because I guarantee it'll show up. A store had pants on sale for 37% off. If they started at $40, what is the sale price? And you would have a calculator for this on the MOCA, so it's okay to use your phone to figure that out. Alright. The easiest way to think about sale prices, in my opinion, is to think, how much am I going to pay for this? And while that seems like kind of an obvious question, so if we have 37% off, I like to think, what percent of this am I still paying? So then we could take 100%, which would be the original cost, subtract 37%, and we're left with 63% that we still have to pay. So after we figured that out, we can just multiply the original price of the pants, which was $40, by 0.63, which whenever we turn percents into a decimal, that's we know that they're out of like 1 instead of out of 100. So if you multiply this we come up with $25.20, which is the remaining price that you would have to pay. Okay. A car is traveling at a speed of 100 kilometers per hour. What is its approximate speed in meters per second? Alright. So we know that we're going 100 kilometers per hour. So in order to get that to meters per second, we're going to need to work with both our distance and our time conversions. Okay. So I like to pick one and stick with it for a minute. So we're going to talk about time. There's 60 minutes in an hour. So if we multiply this by 60, we'll get the kilometers per minute. So that would be this. There's 60 seconds in a minute. So if we multiply this by 60, then we'll get the kilometers per second. Then we know that we've taken care of our time. So now it's time to switch to our distance. The easiest way to convert the metric system is to think about kangaroos hop down mountains drinking chocolate milk. So we're here at kilometers and we need to get to meters. So the metric system is all based on a base 10 system. So we can move our decimal point 1, 2, 3 places in order to go from kilometers to meters. So if we started with our decimal point here, we go 1, 2, 3. So then we're left with 360 kilometers or meters per second, and somehow I did that wrong. Or the answer is wrong up there. Okay. Ridiculous. I took that on the wrong side. Your decimal point goes on the other side, and then you move it 1, 2, 3. That's how you're left with 36 meters per second. So that's how we got that answer. Alright, which of the following graphs would be most useful for showing a correlation between variables? Okay, so with this one, we can use process of elimination. Histogram usually only tells one variable, so you might have test scores or attitude scales or any kind of like one variable data. The same thing goes for a box and whisker plot. So then we're left with a scatter plot and a double bar graph. Both of these are good for comparing two things, but the best method for showing a complete correlation is to use a scatter plot, because then you can draw trend lines and see how well the trend lines compare to one another. With a double bar graph, you can see how things are going up and down, but it's hard to see how their overall trend is going. Which description best describes quadrant 4 of the Cartesian plane? Alright, so when we're presented with a graph like this, we have section 1 is this first one, and then we go counterclockwise. So then this would be 2, this would be 3, and then this would be 4. So then after we see that, we look at what our X's and Y's are doing. So we know that in this quadrant 4, these are all going to be positive X's and negative Y's. Any irregular polygon cannot have which of the following types of symmetry? Alrighty. So let's think about our types of symmetry. Vertical symmetry would be up and down. Horizontal symmetry would be side to side, like the horizon. Reflectional symmetry means that if I reflect it over a line, it's still going to be the same. However, rotational symmetry has to have all of the other components. So in order for you to have rotational symmetry, it also must be vertical, horizontal, or reflectional. So with an irregular polygon, it could be true that it could have vertical symmetry at some point. It could have horizontal, but it's not going to have all of them. And that's why it could not be rotational. Identify the interquartile range for the scores on Miss Medlin's math test. When we talk about interquartile range, we're looking at what's inside the box. So we're looking from 65 to 90. So to find that range, we would take the biggest number at the farthest end of the box, 90, and subtract the beginning of the box, 65. 90 minus 65 is 25. So that would be our interquartile range. Identify the prime factorization of 1250. Which one? Red is 5 cubed. Yeah. Okay, so the easiest way to find this, and I know you were probably tempted to go ahead and plug each of those into your calculator and work backwards. But the easiest way to actually do this, and probably the fastest way, would be to do a factor tree like we saw earlier. So whenever we're doing a factor tree, you're trying to identify all the prime numbers that go into a number. So I like to start out easy. You have 10 times 125. Okay, can our 10 break down farther? Yes, it can. You have 2 times 5. And our 125 also breaks down into 5 times 25. And our 25 breaks down into 5 times 5. Since the only numbers that can go into 2 and 5 are 1 and themselves, those would be prime numbers. And we see that there's 4 5s, excuse me, multiplied by 1 2. So this would be the prime factorization of 1250. All right, solve this equation. Yes, sorry. There's no protocol for typing in fractions on Kahoot. So like the first one would be 2/3, the second would be 3/4. All right. So we have 2/3 divided by 3/4. And all of this is multiplied by 3. So in order to divide fractions, we multiply and flip the second fraction to its reciprocal. So we would have 2/3 multiplied by 4/3 multiplied by 3. So when we multiply fractions, we can just multiply straight across. We get 8/9 multiplied by 3. If you multiply fractions by a whole number, you can put the whole number over 1, and you're left with 24/9. And as we said in the beginning, do not simplify. Krista says that she can make a triangle with sides of 3, 4, and 8. What theorem disproves her? Alright, so our Pythagorean theorem only works on right triangles. That's the one that says a squared plus b squared equals c squared. It's if you know 2 legs or the hypotenuse to find the lengths of the sides. The triangle congruence theorem and concurrency theorem are not actually a real thing. They were thrown in there to throw you off. And that left the triangle inequality theorem, which states that if you add 2 legs of a triangle together, the third leg must be less than the sum of the two other legs. So the reason that this does not follow the triangle inequality theorem is if we add 3 and 4 together, we get 7. So 8 is bigger than 7. So there's no way that they could ever make a triangle out of that. Calculate the volume of a pictured rectangular pyramid. Don't look at this 4 as if it's the height. All right. So this is why I included this lovely formula right here. Volume equals 1/3 times the base times the height. So first I would look at this as if it was just a normal square, even though I know this is not a square, or not a square, a cube. So we would have 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. Now, a rectangular pyramid is 1/3 of a cube. So we have to divide this by 3, giving us 20. So now that we know that we have a volume of 20, we have to think about our units. So we know it's in inches. Area is cubed, or area is squared, and volume is cubed. So our inches, when we look for volume, is going to be to the 3rd power, because you have 1 dimension in height, 1 dimension in length, and 1 dimension in width. So we were going to draw that out like I started to. So we have length times width, but then we also have dimension going like through the rest of it. So that's where the 3rd inch squared or inch comes from. Which of the following cannot be taught to kindergartners before learning numbers? All right. While position, sorting, and patterns can be taught before you understand numbers, you cannot count if you don't know the numbers. That's just the simple answer to this one. Nemo's is selling 17.3 tons of crab a year. If each dish requires 12 ounce, how many can be sold? Alright, so now we're looking at conversions of weight. And so this is why we included 16 ounces equals 1 pound, and 2,000, this is supposed to say pounds, equals 1 ton. So we have 17.3 tons. So in pounds, we would multiply this by 2,000. I want to do that the other way. Which I'm not going to do in my head though. I will left my phone over there. 34,600. 34,600 even. Okay. That's how much that would be in pounds. And then we have to multiply it by 16 to find out what that would be in ounces. And can you give me the math for that one as well? $150,600 ounces. Okay, so we found how much tons of crab a year they sell, but now we're trying to find out how many dishes this is. So we're going to have to divide this by the number of ounces it takes to make a dish, which is 12. And that should equal to 46,133 dishes. If there is a decimal that went past that, you would cut it off at the one before it because you can't serve half a dish to someone. Dr. L has 5 times as many B's than A's in a class of 24. If 2 B's change to A's, what's the ratio? So whenever you see a question like this, I want you to think about how can I put this in a graph or a chart? Not a graph, a chart. So if we have 5 times as many B's than A's, that means for every 5 B's, we have 1 A. So we have 5 B's, we have an A. We have 5 B's, we have an A. Okay, so this first one made us 6. This made us 12 now. Now we have 18. And now we have 24. So this will tell us how many had B's and how many had A's out of the class of 24. So then we're asked if 2 of these B's are turned into A's, what is the ratio? So now we'll add them back up. We have 5, 10, 15, 18 to 6. And I know I said don't simplify earlier. This one you actually have to simplify to find a ratio. So 6 goes into 18 3 times. So our ratio, 6 goes in there. 6 goes into 6 1 time, so our ratio is 3 to 1. Yeah. Mm-hmm. 6 times 10. Yeah. Mm-hmm. And then 6 times 4 is 24. Yeah, so what I was doing is I was saying, like, after we do, like, we know it's 1 A for every 5 B's, so we know that's 6. And this would be another 6, so add them together. Does that make sense? Okay. Alright, Daryl said the angles of an acute triangle were 29, 50, and 101. What is his error? Alright, you guys all got that right. If Daryl was describing a right triangle, one of these angles would have to be 90 degrees. The sum of a triangle is 180 degrees, so it can be the right answer. And the measurements cannot be the angles of a triangle. Any measurement could be the angles of a triangle as long as it adds up to 180. So the answer was an acute triangle can have no angles over 89 degrees because 90 degrees would be right and 91 on would be obtuse angles. Alright, find the area of the following shape. Okay. The first thing I want to do is point out that this triangle right here, if we moved it over here, we would have a rectangle. So let's think about the height then. If we made this a rectangle, this is a special right triangle. So this side would be 4 because it's a 3, 4, 5 triangle. If you can't remember that it's a special right triangle, you could have also done Pythagorean theorem, and you would have came out with the same thing. So then we're gonna forget that this part was ever right there. So we're only looking at this little chunk right here. So then 8 plus 3 makes this whole length 11 times 4 to find the area equals 44 units. And all the units here are squared, and we know that area is squared because it's only 2-dimensional. Using rounding, formulate a reasonable estimate for the mean of the following set of data. Sorry. Alright, so in this one, you would round them to the nearest whole numbers. Anything less than 5 rounds down, anything 5 or bigger rounds up. Add them all together and divide by 8 because that's the number of numbers that are here. And then if the number you get is a decimal, round that number to the nearest number. Shakes have 3 flavors. If 2 people have random ones, what's the probability they'll be the same? Alright, So the first question I want us to ask ourselves, if I go to the Shake Shack and I order a chocolate milkshake, does that mean that Allison could also order a chocolate milkshake behind me? Yeah. So, because unless they magically ran out of chocolate shakes, you're not gonna have it to where the person that comes behind them is not gonna be able to have the same outcome. So then, after we've decided that everybody can pick the same thing if they wanted to, we have to think about how many choices we have. So we have 3 different types of shakes, it doesn't matter what kind. And if I pick one, I have a 1 in 3 chance of picking chocolate. And then in order for it to be the same thing, there's a 1 in 3 chance that somebody else will pick chocolate. But to find the probability that they'll be the same, you have to multiply these. And when we multiply fractions, we just go straight across. So 1 times 1 is 1, and 3 times 3 is 9. So there's a 1 in 9 chance that 2 people would pick the same kind of milkshake. Which of the following numbers would appear next in this series? This is actually a middle school math question, but I threw it in just to see if anyone could get it. Alright, so in this series, the numbers are increasing. So if the numbers are increasing in this series, it means that we're not going to have any subtraction, division, or square roots. So then we have to think about what is being added, multiplied, or squared. And in this case, we start at 0. 1 squared is 1. 2 squared is 4, so 1 plus 4 is 5. 3 squared is 9. 5 plus 9 is 14. 4 squared is 16. 14 plus 16 is 30. 5 squared is 25. 25 plus 30 is 55. So then we would have to add 6 squared, which is 36. So 55 plus 36 equals 91. Rectangle A and B are similar. A is pictured If the area of B is 576 millimeters squared, what is its perimeter? I'm gonna take a seat. Alright. This is my least favorite question out of this whole entire review. If you have been here before, you know this. Okay. When two rectangles are similar, they have a ratio between their sides. So this is our first one that's given to us. And then we're given another rectangle that the only thing we know about it is that it has an area of 576 millimeters squared. So the best thing I can tell you to do with this problem is to guess and check. So 9 millimeters and 4 millimeters. Alright, Heather, what do you think they might be multiplied by? 2. Okay. So, if we're multiplying these by 2, we would have legs of 8 and 18. So, 8 times 18 is 144, so it's a little too small. Okay, what's another number they might be multiplied by, Lauren? Think bigger than 2, smaller than 5. Okay. Alright, 9 times 4 is 36, and 4 times 4 is 16. If we multiply these together, we get 6, 3, 9, 0, 6, 3, 6. Did I do that wrong? Yes, I did. Not bad. 63, 18, 3, 21. Alright, we get 576 as our area, so we know then that this leg is 36 and this leg is 16. So now we have to find the perimeter of this square. So that would mean this side would also be 16 and the top would be 36. Which would add up to be 104. Bo has 96 Legos and wants to give an equal number to his 6 friends. Which operation would Bo use? Great job. So whenever we want to divide something among our friends, we would use division. It's kind of some common sense here. Which of the following is the slope of the line 4x minus 9y equals 12? Alright. So if we were to work this problem out, we would have 4x minus 9y equals 12. And whenever we have it in slope-intercept form, which is the easiest way to identify the slope, we are isolating the y to one side. So, like we did in the earlier problem, earlier on, we're going to be isolating the y and everything, we're going to be undoing what's been done. So, in order to get rid of this 4x, we'd have to subtract it from each side. Alright, and then to undo this division, we would divide by 9, or negative 9. So whenever I have two negatives right here, they make a positive. But whenever I have one negative and one positive, they equal a negative. So then we're left with this as our slope, 4/9. Calculate the sum of the interior angles of a regular decagon. Okay. So in order to find the sum of the interior angles of a regular shape, you can use this formula right here. So we would have n minus 2 times 180 degrees. So our n comes from the number of sides of the shape. So a decagon has 10 sides, isn't it? Yeah. So it has 10 sides minus 2 times 180. So 10 minus 2 is 8 times 180 degrees is 0, 4, 64, 8, 14. It's 1,440. And then this is degrees, since we're talking about angles. We're almost done, guys. Okay. Just like continue writing your answers down. It'll be fine. Oh. Did the internet go out? Okay. Well, just keep writing your answers down. Because we're almost done. Oh. Alright.
Computer doesn't know how to do it anyway, so
you're good. So, Amber, since you're the Heather, since you're the only one that's still in, can you wait towards like the end of the 90 seconds to like put your answer in? Okay, you're good. Okay. So we know from the very first question of this that vertical angles have the same measures. But there's also a special relationship between adjacent angles and that they equal 180 degrees. So, if we were to imagine that this 45 was where this 3 is, because those are the same measurements, because of the way two lines cut by transversal, they're going to be the same, they're complementary, or that is not the right word. They have the same measurement, they're congruent. So if we imagine this 45 up here, we could add these together to get 180 degrees. So to find x, we'd have 45 degrees plus 5x plus 35 degrees equals 180. So first we would gather our like terms. We'd have 5x plus 80 equals 180. To undo this addition, we would subtract from each side, giving us 5x equals 100, and x would equal 20 degrees. Two more questions, guys. Which of the following could be a completed view of the cube? Alright, so in order to do this, you have to think about what parts were being shown. So we're not being shown this part or this part. So that leaves us potentially looking at these four. Okay, so I would start by looking at this position, and we see there's one thick line and one thin line. So this one's gone because it's two thick lines. Alright. To the right of it, we have a line going up. So that gets rid of this one, because there's no line going up. So now we're left looking at this right here. So if we folded this over like it was the top of the box, we see that these two meet up. These two would meet up. These two sides would meet up. And then these two sides would meet up. So now we're looking at what parts of this would touch what parts of that. And if we rolled this all the way around, we would have this corner right here being closest to the black part. And that's how we got A. Alright, and our last question. What is the ratio of weight between the red and yellow hearts? Alrighty. Okay, so we're looking at the ratio of red and yellow hearts. So that means that anything that involves green, we don't have to pay attention to. So this is another time where the test makers are going to try and distract you. They're thinking, okay, I'll get them thinking about this irrelevant thing, and they'll waste time and then not get to questions later on. So the only one you had to look at was this one right here. So we can see that for every one yellow heart, we have two red hearts. But the question asks us, what is the ratio between red and yellow? So we would need red first to yellow. All right, that is the last question of the review. If you went back and counted every question that you got right, and it is 30 or more, you would have passed the Math MOCA. If you have less than 30, you wouldn't have passed, but there are more chances to bring it up. After Friday, the 20th, this will be available online as well as Form B, and all of the worked out answers and explanations will be available through Dr. Bohannon, and also on the Moodle page for all College of Education members. So that's all I have for you guys.